Hello, this is Mr. Holly, and I will be teaching Module 2, Lesson 2. The point of today's lesson is to use number lines to model the addition of integers. So we will be adding positive and negative numbers using a number line. If we look at exercise 1, it gives us a real-world situation. It says, suppose that you received $10 from your grandmother for your birthday. You spent $4 on snacks. Using addition, how would you write an equation to represent the situation? So when I read this, I want to do some marking up of the text, make some observations, and you're going to think back to 6th grade. In 6th grade, you were able to identify positive and negative numbers. If I look at this and I see the term received $10, is that a positive integer or a negative integer? Okay, I'm thinking about this. That is a positive 10. As a positive integer, it is 10. You spent $4 on snacks. So if I see that I spent 4, I have to think, okay, that would be a negative integer, negative 4. Now I'm going to remind you of some vocabulary from Lesson 1. In Lesson 1, I talked about vectors, which have distance and direction. We will continue to use that vocabulary. The number 10 is positive, therefore its direction will be to the right. It has an absolute value of 10, therefore its distance will be 10. It will have a length of 10. Negative 4, that has an absolute value of 4, and therefore its distance will be 4 units long. It has a direction, it is a negative integer, so its direction would be to the left. I'm going to model this on a number line, and I'm going to walk you through this procedure in the next problem, so I'm just going to model it at this point. First, I'm going to do the vector of 10 to the right. That is because this number is positive, so we're going to the right, and it's 10, so it should have a length of 10. And then negative 4, which will be 4 units long, and go in the left direction because it's negative. When I stop, I see that my answer is at 6. So the question asks to write an equation. I would write that as 10 plus negative 4 is equal to 6. Okay, looking at example 1, it is very important that you learn this procedure for modeling addition on a number line. You will have questions both on your module test and on any year-end test like a TN Ready that we would take. I would almost guarantee that you will have a question and it will ask you about a number line, and you will have to make observations about that number line using this procedure. Okay? So, the procedure, we're going to complete the steps, or the procedure here, to find the sum of negative 2 plus 3 by filling in the blanks. Model the equation using straight arrows, called vectors, on the number line below. Place the tail of the arrow on 0. Our first arrow will begin at 0. We will always begin at 0. Always begin at 0. You may have questions in the future where something is modeled on a number line. So ask what's wrong with it. The problem is they didn't begin at 0. We always begin at 0. So we're beginning at 0. We're going to draw the arrow 2 units to the left of 0 and stop at negative 2. The direction of the arrow is to the left, since we are counting down from 0, and because we have a negative number, that tells me my direction is to the left. So I'm going to model that. Start at 0, draw the arrow to the left. That is a vector of negative 2. I like to label my vectors. Okay. Step 3 here, C. Start the next arrow at the end of the first arrow. That's important. My next arrow starts here at negative 2. I'm going to go ahead and just fill in a circle here, just a dot at -2. And it says we should go, it's -2 plus 3, so that next vector is going to have a length of 3. We are going to go 3 to the right, and we are going to stop at 1. We went to the right because 3 is a positive number, therefore we go to the right. Stop at 1. That would be our answer. So I could write the equation -2 plus 3 is equal to 1. All right, let's continue. I'm going to repeat the process here to do 3 plus -2. Start at 0. 3 has a distance of 3 and a direction to the right, so I'm going to go 3 spaces to the right. -2 should be 2 units long, and it's negative, so it should be to the left. -2. That leaves me at 1. 3 plus -2 is equal to 1. Question H asks us, what can you say about the sum of -2 plus 3 and 3 plus -2? Does order matter when adding numbers? Maybe you are familiar with this already, but in addition, the numbers can be added in any order. We call that the commutative property of addition. I always like to bring in some kind of word association with vocabulary. Maybe you've heard the term morning commute before, or somebody that goes to school but doesn't live on campus is called a commuter. Commute means to travel or to move. So with the commutative property, I can actually move the numbers around in any order. I could have -2 plus 3, or I could move the numbers and have 3 plus -2. All right, moving on to the next example. Example 2, expressing absolute value as a length of an arrow on the real number line. How does the absolute value determine the length for -2? Use the number line provided to support your answer. This has already been given to you in the vocabulary, and we're going to continue to emphasize that the absolute value of the number tells me the distance of the vector. Because -2, the absolute value of -2 is equal to 2, I know that the length of this vector will be 2 units. It will go to the left direction because it is -2. Same thing for 3. I would begin at 0. I would travel 3 units to the right. I know that the length of this vector is 3 because the absolute value of 3 is equal to 3. C. Describe how the absolute value helps you represent -10 on a number line. I know that the absolute value of -10 is 10. So I would be drawing a vector that is 10 units from 0. Because it's negative, I would travel to the left. Let's continue to our final page here. Exercise 2. Create a number line to model each of the expressions below. Here I have, starting at 0, I'm going to go 6 to the left because the absolute value is 6, and the sign is negative, which tells me to travel to the left. -6. I begin my next vector at the end of the first vector, and I'm going to travel 4 to the right because this number is positive, which means I will travel to the right, and it has an absolute value of 4, which means I will travel 4 spaces. This means I stop at -2, And I can say negative 6 plus 4 is equal to negative 2. All right, 3 plus negative 8. Start at 0. 3 is positive, so I go to the right. Negative 8. I need a vector that is 8 units long. It is negative, so I'm going to travel to the left. I want to show you a trick. If I have traveled 3 spaces, how many more spaces do I need to travel? I traveled 3 to get back to 0. How many more spaces do I need to travel so that I can travel a total of 8? Well, 3 and 5 is 8. So I travel 3 to get back to 0, and then an additional 5 spaces, and that's going to get me to negative 5. So this entire vector is negative 8, but it is nice to break it up and see that we are able to create a 0 pair and know that I would have 5 spaces left over, and that's how far I would need to travel in order to get to negative 5. Hopefully this representation here helps you to kind of see how when we add numbers that have different signs, like a positive and a negative, some of the positives and some of the negatives cancel out, a positive 3 and a negative 3, to create 0, and then I have a remaining negative 5. 3 plus negative 8 is equal to negative 5. All right, example 3. Find the sum of the integers represented in the diagram. Write an equation to represent them. How do I know which one comes first? Oh, we always start at 0. That means 5 must come first. The next arrow, the next vector, is going to be negative 2. And then the next vector is going to be 3. I can find the sum by looking at the movement using the vectors. 5 to the right, 2 to the left, and now 3 to the right is going to put me finishing up at 6, which means my sum is 6. We will not get to physically play the integer card game. We're going to teach you a version of it. You should already know that. But if we were to represent these with playing cards, we would represent them as 5, negative 2, and 3. That's what the question asks us to do. Okay. In what ways does this model differ from Lesson 1? Well, we introduced this in Lesson 1, but we are really honing in on the idea that these are vectors. We are not just counting 1, 2, 3, 4 and counting up. These are vectors. They communicate distance and direction. Can you make a connection between the sum of 6 and where the third arrow ends on the number line? Well, the third arrow ends at 6, and that's how we determine our sum when we're using addition on a number line. If we model addition on a number line, we are going to track the movement using these vectors until we arrive at a sum. This number that we arrive at finally is our sum. So we could say that the relationship is that the third vector ends at 6. Question E asks, would the sum change if we change the order? For instance, if I wanted to add negative 2 plus 3 plus 5, would that change the sum? And the answer is no, because of the commutative property of addition. We've already established that you can move those in any order. The new question is, would this affect our diagram? And the answer to that question is a definite yes. It would affect your diagram. Okay? We would need to model that with a vector of negative 2, a vector of 3, and then a vector of 5. And that still would put us at 6. All right, excellent. So our goal today was to model addition on the number line. I hope that you guys feel confident in your ability to model that addition. Thank you.